Okay, on page 49, I did not put any review problems in your packet this time, but I did put textbook pages and problems to try out. All right, on page 49 of your packet, can you guys flip over page 49 for me in your packet? You'll see the answers to those textbook questions right there for you. Okay, you will see the answers to those. Okay? Now, I get it. Some of you need more than the textbook. Maybe the textbook problems are just too easy for you and you need a little bit more of a challenge because tomorrow will be a challenge. On Aspen, on our webpage, I've put 2 different review questions on there. One says more practice for the unit test. And this is a ton. I'm just going to scroll by it real quick, but this is a ton of review questions. I got proofs. I got algebra questions. I got a ton. Are they congruent? If so, why? And then at the end are all the answers to them. All right, a ton of here. I didn't count them up. Here are some more proofs. I didn't count them up, but there's a ton here, all right, for you to try out. The other one is some tougher triangle proofs, all right, because one of the questions on there is going to be one of the tougher triangle proofs tomorrow on the unit test. How many do I have? 3, 4. Yes, I have 4 tougher triangle proofs with the answers to them. All right, so there's more than enough resources for you guys to prepare if you choose to prepare. Because I know some of you are going to say, whatever. But hey, that's on you. Okay? All good. So everyone knows where it is? Yep. What's up, Helen? I'm going to go over that in a second. Yep. I'll go over everything will be on there in a minute. So we all good on where all your resources are, and I'll be here today after school. All right. So going to Helen's question, which is, what's the deal on tomorrow's test? You got it. 45-pointer tomorrow. First grade of the second quarter. There's 3 proofs total. 3 proofs. One of them is going to be an 8-pointer, which will probably be the tough one. All right, and I will let you know off the bat it's going to deal with an isosceles triangle. Prove to me that it's isosceles. All right, that's the big one tomorrow, 8 points. There's going to be 2 smaller ones, which are 6 points each. All right, 2 smaller ones. I will have you graph a triangle. I will give you 3 coordinates. You'll graph it on the piece of graph paper I give you, and I want to know if it's scalene, isosceles, or equilateral. If it's scalene, what do you know about the sides? No sides congruent. If it's isosceles, what are you going to know? 2 sides congruent. And if it's equilateral, all 3 sides congruent. How are you going to tell that? What am I trying to get at here? What do you have to know coming into tomorrow as well? How are you going to know which the lengths of the sides? Distance. Yep, there you go. Okay, because I'm not going to take, it looks congruent, so it must be isosceles. No, sorry. You're going to need to show me the lengths of the 3 sides. All right, using distance formula. Or Pythag. I don't know if some people are Pythag people. Congruent, the rigid motions. Don't worry too much about the rigid motions. All I'm going to show you, here are 2 triangles that are congruent. What did I do? Did I reflect? Did I translate? Did I rotate? Okay, don't get too freaked out about that. Missing variable coordinates. That's what we've done the last 2 days. I'm talking about in your packet, page 46 in your packet. Okay, page 46 in your packet where I tell you it's isosceles. What's my missing coordinate? All right. And then can't forget about this. It seems like it's been forever. What are my 5 ways of proving triangles congruent? All right, here we go. One way, and I don't have time to do the numbers today. Avery, let's go. Side, side, side. Thomas got another one. Side, angle, side. Where else are we going here? Go ahead. Angle, side, angle. We're almost there. Julia. Angle, angle, side. And the one people always forget, Mason. HL can only be used in what type of triangle? Right triangle. But just because you see a right triangle, don't assume it's HL. It could be any one of these. All right, could be any one of these. Oh, what is still not up here? Yeah, CPCTC, not a way to prove triangles congruent. Guess what else is still not up here? Angle, angle, angle. Can we not put it on our test tomorrow? Please. I'm almost begging you. Please don't put it on. Please don't put side-side angle on. Please don't put third angles on. Third angles theorem. It's not a way to prove triangles congruent. Okay, these are only 5 options. All right, nothing new tomorrow. All right, nothing new. Is there anything before I go to the textbook? Is there anything you want me to elaborate or touch upon? Because I'll give you anything you want. Okay, I don't care. I'll give you anything you want. I have no problem giving you most of the test. It's what you do with it that counts. Anybody want to ask anything? We all set. Nobody? Anything on here? Either you want me to go over, or you want me to get more detail with. Hi, Fiona. Correct.
Is that the one where like you would have to split up the triangle in half and then find
I'm going to tell you what type of triangle it is. Okay. I'm going to give you 2 points, and I'm going to say what's the missing point.
like 2 lines like
Yeah, here you go. Ready? Doesn't look it, but I'll tell you this triangle's isosceles. All right. Let's say I'm going to 0, 0. This will be 5a, 0. What's your missing coordinate C? If it's isosceles. So halfway would be 2.5a. And then since it's isosceles, this can be anything. Okay. If it's, now let me change this. If it's equilateral. Anybody remember 2.5a? Radical 3. Yep. Because I don't think anybody wants to do the old pi fag tomorrow. Okay. So if it's equilateral, it'll be half that radical 3. Yep. Good question. Anybody want to go anywhere else? Yep. Yep.
Is that just going to be like...
I'm going to give you 2 triangles on a graph. Did you reflect, rotate, or translate to get to the other one? That's it. I'm not going to go nuts there. We got a whole unit dedicated to that coming up sooner or later this year. All right. To the textbook now. Let's start with page 310 for me, please. Page 310. There are certain questions I've picked out to see where we are and just help you find out where you are. Okay, I'm going to start with number 5. Number 5. On page 310, number 5. Is it correct? Is that statement correct? And if it's not correct, fix it. All right? If it's not correct, fix it. The vertex angles of an isosceles triangle are congruent. True, false? What do we think about that statement? The vertex, we got to know our vocab for the isosceles triangle. How many sides congruent in an isosceles triangle? Let's start there. What are those sides called? In an isosceles triangle or in any triangle, what do you know about the angles across from the congruent sides? They're congruent. Anybody remember the names of those? What's the name of the non-congruent angle called? That's the vertex. And what's the name of the non-congruent side? So is that statement true or false? False. How do you make it true? Replace vertex with base. Yep. Okay. Because tomorrow, if we do an isosceles triangle proof or any type of isosceles triangle problem, I'm not going to say, listen, I'm not going to say the non-congruent angle. I'm going to say the vertex angle. 27. Go to 27 for me. Are those triangles congruent? If they are, tell me why. And if you don't think so, just tell me not possible. 27, please. 27. Are those triangles congruent? If they are, why? One of the 5 methods. And if they're not possible. Anybody want to give anything up here? Want to try it out? Take a leap? Hi, Billy. Why? Where's your angle? Where's your angle? That's I'm asking you. Where's your angle? I don't see any angles marked, right? Where's your third side? This one? 95% of you just fell into the side trap. Ready? You only have one pair of sides congruent, and that's the reflexive side he just gave me. What's that side congruent to? Another side, but it's in the same triangle. They have to be congruent in both triangles, yes? So everyone see a little trap right there. So this is a not possible one. Do we see that? They have to be congruent to a side in the other triangle, not the same triangle. All right? Yep. That's why I picked that one, just to be a heads up. We all good? All right. Proof number 29. Proof number 29. I'll give you a second if you want to set it up or not. Before we start this one, I just want to give you a heads up. The 3 tomorrow are not as easy as this one. All right, so please do not get an ego going. This is easy. I'll be fine. No, nope, nope, nope. I'm being honest with you. The 3 on there tomorrow is not as easy as this one. Colored pencils, highlighters, feel free to bring them tomorrow and use them if you'd like. Anybody remember the symbol we use for parallel on a diagram? Okay. Again, not as easy as the one tomorrow. Maybe, I don't know how you're going to feel then. I gave you a pair of sides, A, B, and DC. You guys got to find me 2 other pair of something. I gave you A, B, and DC. Can anybody see anything else? I really don't want to keep going here. What do you got, Fiona? Angle, okay, I agree with angle A, but I don't like angle C because there's multiple angle C's here. DCE, got it. So those 2 angles. Nice job. You good? I could say angle A, that's fine because there's only one angle A, but there's a couple angle C's there. So DCE. Anybody know why she's correct? What type of angles did Fiona just give me? Alternate interior. And how do we start this reason? Parallel lines imply alternate interior angles congruent. Okay, nice job. Thanks, Fiona. Got me a pair of angles. Anybody got any other pairs of anything for me?
I have a question.
Sure.
Could you have done angle ABE and then angle EBC?
You want to do that?
Yeah, no, I was just wondering if you could do that.
Yeah, why not?
Okay.
What type? Those are also alternate interior, yeah. And while we're on this, why not? Angle ABE, can't call it angle B. Congruent to angle, I can call that angle D. Yep, same reason. So I just put it in statement 2. And then I think we're done. If you wanted to say the verticals, anybody going to tell me the vertical angles? That's fine. Go ahead, put it in. It's correct. You're proving the triangles may be a little bit different than what we have up here, but that's correct. The vertical angles. Don't be this, and I'm being, don't be this embarrassment. Angle E congruent to angle E. I get that every year. Reflexive. They're not the same angles, and they're vertical. All right, you're better than that. All right. So the way we did it as a class, what method out of those 5 are we going to pick here? Side angle, side. Angle, side angle. If you guys prove the vertical angles, it's probably going to be angle, angle, side. Hi, Fiona.
Can we do like BC and then like BC reflective?
Okay, but BC is not in those 2 triangles.
It's on the back.
Yeah, it's right here. It's not a side in those 2. I'm trying to prove congruent. Remember, I'm trying to prove these 2 congruent. No, just these 2 right here that I highlighted. That's the ones they wanted to. If you were talking about the overlapping ones, yes, you got a reflexive there. Anything else? I don't know how you thought that would be, how you thought that was, but tomorrow I'm going to be a little bit tougher. All right. Now I got a little algebra for you. Can we go to, actually not yet, page number 40. Number 40. I think, Fiona, this is what you were kind of asking me before. Can you guys draw me an isosceles triangle with those conditions up there? It's got to be isosceles. What's this mean again? I know we just went over it, but base. That's the base of an isosceles triangle. The non-congruent side. All right. It's got to be 2A. So I'm assuming most of you guys will start at the origin, I hope anyway, with either W or Y. So we can start at 0, 0. What's your coordinate for Y then? 2A, 0, yep. All right, and then let's see, what am I left with? X. What do you got for the X coordinate here? Halfway in between for isosceles. What's my X coordinate? A, okay, and then I get it. Usually I let you pick whatever you want for isosceles, but there is another part of this. What do you got to know about this triangle? The height is H, so it's got to go up to H in this case. Yes, the height of it. It's got to go up to H. Just to keep you on your toes, what if I said this was equilateral? Forget about the height. It's just equilateral. This would be A, comma, A radical 3. Yes, A radical 3. Okay. Page 315 now. Let's go algebra. Have calculators out, please. We're not going to do this for you. Have some calculators out. Page 315. We're going to number 11 on page 315. Need your help getting to angle X. Need your help getting to angle X. Again, page 315, number 11. What type of triangles am I giving you there? Both of them are what type? Isosceles. So automatically we know what's across from those congruent sides. Congruent angles. Perfect. So let's start with this triangle that's got a vertex angle of 116. You're telling me those angles are congruent. Got it. All right, I'll grab my calculator too here. Can we find those angles for me? Let's see, 180 minus 116. I got 64 left, but cut that in half. What's each angle here? 32, and they want to suck you in right away, huh? By putting 32 as an answer. We're not done yet. How am I going to get over to this triangle? Emma, what's up? 2, sorry. Yep. I should have told you guys, assume that was a straight line, 180 degrees. So 180 minus 32 minus 72. This angle right here, 76. You guys said this was isosceles. What's across from those two congruent sides? Congruent angles, one of which was 76, meaning the other 76. And we know there's 180 degrees in a triangle. So 180 minus 76 minus 76. That angle X, 28. Yes, Thomas. You're looking at it, really. Put in those angles for me. Yeah, put in those angles for me. So I know how you got. And honestly, because it's multiple choice, I wouldn't need to see any work. But if it was non-multiple choice, just write in the angles on the diagram. Okay. All right, and then number 19, same page, number 19, or maybe a different one, I don't know. But number 19, same part of your book. Help me get to angle 2 now. Help me get to angle 2. Right off the bat, which angle do you know? No calculations needed. Angle 1 is 66 in a triangle. Congruent angles are across from congruent sides. So that's 66. Knowing that now, which angle can I go to now? Angle 3, yep. 180 degrees in a triangle. Angle 3 would be 48 degrees. All right, still not to angle 2 yet. Where else can I go? Angle 4, yep. What do you know about angle 4? 180 minus 48, angle 4 will be 132. And then how can I finish this now to find angle 2? 180 minus, yep, 132 minus 24. Angle 2, 24 degrees. All right. Questions from you guys? I think that's the last one. I wanted to go. One last thing. Hold on. One last thing. Angle 2 plus angle 4. Yep. Keep that in mind. All right. Keep that in mind. All right. You got a lot of different paths. You can continue on with the textbook. You can open up the extra problems, or you can open up the tougher proofs. It is up to you. I'm going to walk around making sure you're working on one of the 3 and then answering any questions you have. This is not like an optional thing. We're working on one of the 3.